suppose I do circle, star, triangle, square, okay, in my circle. Is this a different pattern?
No, it's not. It's not.
How would you know? I haven't even drawn it yet.
Yeah, we don't know what you're going to do. We're psychic.
Is that a different pattern?
No.
Why?
Because what you did is rotated.
Yeah, it's just like you took the circle and you rotated it. So if you rotate it and it's still the same pattern, that doesn't count as a new pattern.
You have to actually move.
You actually have to move pieces into different positions. So that actually means you have less patterns when you're doing circular permutations. So if you are doing all of the objects, well actually can anybody guess what it is? Normally if we were doing 4 objects we do 4 factorial, which is 24. Okay? Do you think there's any way I'm going to come close to 24 ways if I can't rotate it and make it be different? Yours. Why'd you say 8?
Because Kobe just guessed. And it was right.
Okay.
Because you said why.
Actually, it turns out normally I would have you sit there and make all these patterns, but we're running out of time. There's actually 6 ways you can do this in a circle. So why 6? Why would there be 6? What does that have to do with the 24? You do 4 factorial, but then you had 4 different positions. You could rotate it to 4 different positions. So you would divide by that number. You would divide by 4. So if you're doing all the objects, you can say it's n factorial divided by n, which should be the same as what? 4 factorial divided by 4. Just think about that. That's yeah, because does it just cancel the 4s? So it only leaves you with 3 factorial 3, 2, 1. So yeah. So yes, or it's the same thing as doing n minus 1 factorial. Doesn't matter.
This is actually crazy.
What do you mean? I don't know what you're talking about. Okay. Now, 6 points. Suppose this was a plate. And suppose the plate had been chipped right here. You had a little chip spot on the plate. So you could actually tell a starting point on the plate. If you can actually tell a starting point, now can you say when I rotate it I have the same pattern? No, because then I worry about, the square is closest to the chip, or the triangle is closest to the chip. So if I have a starting point, then it's just normal. If there's a fixed point on that circle somewhere, you just do the regular factorial like it's a line. Okay, now I've proven my point. And I'm pausing this for the viewers out there because you're not going to be able to now. So if it's reflective, if you can see it from 2 sides, you take your answer and you divide it by 2. So if you're talking about a necklace or something that you can turn around and see from both sides, it counts. If you're talking about people sitting around a table, are they going to be reflective? Can you flip them over and look at them from the other side? And I don't think you're going to crawl under the table. That would be really strange too. So sitting around a table, sitting around a campfire is not reflective. But if it's some object, if I ask you, I think you have a problem with the cars on a Ferris wheel. On a Ferris wheel, you can see from 2 sides. That's reflective. Enjoy.